Yes. So now today we are going to discuss about our module 3. Okay. So what is our module 3? Functions of single and several variables. So that is our module 3. I will tell you. Okay. So now we'll discuss about our module 3. So what is our module 3? Functions of module 3 name is functions of single and several variables. Several variables. Okay. So in this we have two chapters. So first chapter is that is the functions of first chapter is the functions of single variable. Functions of single variable. Okay. So functions of single variable means that is based on mean value theorems. Okay. So in the functions of single variable, we have mean value theorems. Mean value theorems. Okay. So here in our syllabus, we have only 3 mean value theorems are there. So in our syllabus, we have only 3 mean value theorems are there. So first one is Rolle's mean value theorem or Rolle's theorem. And second one is Lagrange's mean value theorem. Lagrange's mean value theorem. And third one is Cauchy's mean value theorem. Cauchy's mean value theorem. Okay. So our module 3 is functions of single and several variables. In that we are having two chapters. So first one is functions of single variable. So in that in functions of single variables, we have mean value theorems are there. So the mean value theorems in our syllabus, we have only 3 mean value theorems are there. So first one is Rolle's mean value theorem, and second one is Lagrange's mean value theorem, and third one is Cauchy's mean value theorem. Okay. So next, coming to the next chapter. So that is functions of several variables. Functions of several variables. Okay. So in partial functions of several variables, we have partial differentiation is there. Partial differentiation. Okay. So this total chapter will be depends on functions of several variables. So I mean partial differentiation. Okay. So you should learn, you should know the formulas of partial differentiation. Then only you can solve the problems based on functions of several variables. So here the topics of first one is Jacobian transformation. Jacobian transformation. And second one is functions of sorry, not functions of functional dependence or independence. So that is totally based on Jacobian transformation. So if the Jacobian transformation is equal to 0, so then we can say that that is functionally dependent. If the Jacobian transformation is not equal to 0, then we can say that that is functionally independent. Okay. So that is totally depends on Jacobian. Okay. So functional dependence or independence, or functional dependent or independent. So next topic is maxima, minima. Maxima and minima of a function. Okay, so functions of maxima and minima of a function. So in this we have two methods. First one is a function maxima and minima of a function of two variables, and maxima and minima of a function of three variables. Okay, so we have one more method to find the maxima and minima of three variables. We have one more method is there. So that is our last topic, that is Lagrange's method of undetermined multipliers. Lagrange's method of undetermined multipliers. Okay, is it clear, all of you? So in module 3, so our third module is functions of single and several variables. In that we have two chapters. So first one is the functions of single variable, and second one is functions of several variables. Okay, so in functions of single variable, we have mean value theorems are there. So first mean value theorem is what is that? First mean value theorem, Rolle's mean value theorem, and second one is Lagrange's mean value theorem, and third one is Cauchy's mean value theorem. Okay, so up to here, so up to here, one minute. So in functions of single variable, we have mean value theorems are there. We have three mean value theorems are there in our syllabus. First one is Rolle's mean value theorem, and second one is Lagrange's mean value theorem, and third one is Cauchy's mean value theorem. So these two topics already you have studied in intermediate, right? So already you know that Rolle's mean value theorem and Lagrange's mean value theorem. Rolle's theorem and Lagrange's mean value theorem you know, but you don't know about Cauchy's mean value theorem, right? So but up to this, okay, so we have CAE1. Okay, so our CAE1 syllabus is module 1 and module 2 along with the module 3 half part. So module 3 first part. Okay, that means first chapter. So that is in module 3 first chapter we have only three theorems are there. First one is Rolle's mean value theorem, and second one is Lagrange's mean value theorem, and third one is Cauchy's mean value theorem. Okay, so coming to the next chapter. So the chapter is functions of several variables. So here we have partial differentiation is there along with the Jacobian, functional dependent, maxima, minima, and Lagrange's method of undetermined multipliers. So total 4 topics are there in second chapter, and only 3 topics are there in first chapter. Okay, so now we'll discuss about Rolle's theorem. So before going to start Rolle's mean value theorem, so what is the definition of? So all of you listen carefully. So what is the definition of continuous function, and what is the definition of a differentiable function? Anyone? Yes. What happened? Narendra. Yes, tell me what is the definition of. Shall I erase this one? Shall I wipe off my screen? What happened? Put in chat box. Now tell me. Shall I erase the screen? Okay. Okay, very good. Now coming to the, before going to start Rolle's mean value theorem or functions of our first chapter, mean value theorems. So first of all, tell me what is the definition of continuous function? Continuous function. And tell me what is the definition of a differentiable function? When the function is continuous and when the function is differentiable. What happened? Already have told, no? In the previous class only I have told regarding these two definitions. So what is continuous function? The question will be there in the statement only. I mean, in that word only. What is continuous function and what is differentiable function? Yes. So what is continuous function and what is differentiable function, guys? Is my voice audible? Yes. Tell me what is the definition of continuous function and what is the definition of differentiable function? Roll number 94. Means do. Okay. Roll number 73. Tell me, Amma. What is differentiable function? So that is, you are telling, no? Roll number 73. Yes? Are you there? Roll number 73. Okay. So that is possible only in the graph. That is geometrical representation, right? So that is continuously going. There is no interruption in the curve. So that is possible only in the case of geometrical interpretation or geometrical representation or in the graph only. So, but tell me, is there any formula for continuous function? Is there any formula for differentiable function? When the function is continuous and when the function is differentiable? What is the meaning of differentiable and what is the meaning of continuous? C2. 89.
Yes, ma'am.
So what is continuous function and what is differentiable function?
Well, a continuous function is something for every x value there is a real y, and there are no breaks in the graph.
Okay.
If a function is continuous from a to b, then for every x value there exists a real y value.
Okay. So is there any formula for continuous function?
I don't remember, ma'am.
Okay. So what about differentiable function?
Differentiable function. I don't remember, ma'am. I'm sorry.
Okay. Okay, no problem. No issue. I will tell you. So coming to the continuous function. So if the limit value is equal to functional value, if the limit value is equal to functional value, then we can say that that is continuous function. Or there is no interruption in the curve. It will goes continuously, no? in that case, if here we have a point and here we have b point, it will goes continuously. There is no interruption in the curve. Okay, so in that case, that is we can say that that is continuous function. So we have a formula for continuous function, that is a limit value equal to functional value means limit extends to a f of x equal to f of a. Okay, so this is called as continuous function. Okay, so this, what is the meaning of this two? So this is our limit value and this is our functional value. Okay, this is our limit value and this is functional value. If the limit value is equal to functional value, then we can say that that is continuous function. Okay, so coming to the differentiable function. So what is the meaning of differentiable function? What is our differentiable function? So if we have points like this, no, so if it will goes continuously from a to b. Okay, so derivable means or differentiable means at every point a unique tangent will be exist or must be exist. Okay, so at this point a unique tangent will be exist, at this point, at this point, at this point, at this point, every point a unique tangent will be exist, not in the end points. So here 1 point to 2 points, 3 infinity points will exist in the end points. Okay, unit unique here not does not exist unique tangent, right? So more than one tangent will be exist. So that's why always differentiable will be exist in open interval a comma b only. Okay, so coming to the formula, no, so if we have f of x, so we need to calculate f dash of x at x equal to a. Okay, that means f dash of a must be exist. Okay, so f dash of a exist, so means, so that is f dash of x is equal to, so can you tell me the formula, anyone?
Limit
Or
limit
f dash
h
of a
tends to
equal to,
0,
yes, limit x tends to,
0
no, a f of x
plus
minus f of a
minus f of a
by
mm,
a.
by
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 a.
a.
x minus a. Okay, so that means f dash of a must be exist means f dash of a equal to limit x tends to a f of x minus f of x minus f of a divided by x minus a. So this is the formula for differentiable function. Okay, so all of you write down the definitions. So first of all, our module 1, so module 3, that one. So coming to the mean value theorems, our side heading is mean value theorems. Okay, so before that, all of you write down the definition of continuous function. Continuous function. So the continuous function means a function f of x is said to be, a function f of x is said to be continuous or continuous function. Continuous function if, what is the formula? Limit x tends to a f of x equal to f of a. Okay, so limit x tends to a f of x equal to f of a. So this is the main formula for continuous function. Okay, so that means, what is the meaning of this? So the meaning of this formula is limit value equal to
Functional value.
functional value. Okay, so the limit value, this is our limit value, that is will be equal to functional value. 1 minute. So this is our limit value. Okay. So limit extends to a f of x equal to f of a. So limit value is equal to functional value. Then we can say that that is continuous function. Okay. So write down the example problem. Check whether the function is continuous function or not. Continuous function or not. The function is. So here we have actually so many definitions are there, but here I am discussing about this definition, this formula. Okay, limit extends to a f of x equal to f of a. That is nothing but limit value equal to functional value. And all of you check whether the given function is continuous or not. The function is here f of x equal to x square. F of x equal to x square at x equal to 2. Okay, so all of you check and tell me whether the given function is continuous or not. So tell me whether the given function is continuous or not.
Continuous.
So how can you say whether the given function is continuous? Because the limit value equal to functional value, isn't it? So you need to verify. So that means here I am taking LHS. So this is our LHS, right? So LHS equal to, okay. So according to our formula, limit extends to a f of x is our LHS. That means limit extends to a f of x. So we know that x equal to a value is here 2, a equal to 2. Okay, so limit extends to a. So instead of a, we have to write 2. Okay, so that means in extends to 2. What is f of x here? F of x
X
is
square.
X
x
square.
square. Okay, so now limit extends to 2x square means here we have to, instead of x, we have to substitute 2 value, right? So that means that is 2 square. 2 square is nothing but 4. Okay, so here LHS equal to 4. So coming to the RHS. Okay, so coming to the RHS part, what is our RHS? RHS is here f of a, right? So that is our f of a. So here f of x equal to x square. So what is f of a? Instead of x, we have to substitute a. Okay, so that means a square.
A square.
But here, what is a value? A value is 2, right? So now f of 2 equal to, that is nothing but 2 square. So that's why we have to substitute here 2 value, a value, that is nothing but 2. Okay, so you have to substitute here 2. Then what is 2? Instead of x, we have to substitute 2. That means that will be 2 square. 2 square is nothing but 4. So therefore, so from these two, LHS equal to RHS, right? So what is the meaning of that? So therefore, limit extends to a f of x equal to, limit extends to a f of x equal to f of a. So that's why. So therefore, the given function is continuous function, isn't it? The given function is continuous function. So like that we can find it. So accordingly we can do whether the given function is continuous or not. Okay. Shall I erase the screen?
Yes, ma'am.
Yes, ma'am.
Okay. So now write down note all of you. This is most important note. Okay. So every polynomial is continuous function. Every polynomial is continuous function. So means, so if we have polynomial means, what is polynomial? Already I have told, no? In the second unit, in second module, starting day, I have discussed about polynomial. After that, I have discussed about matrix polynomial, right? Did you remember or not? So what about B2? F of x is x cube. So whether the given function is, what about the limit? Limit. You should mention the limit x value also. What is polynomial? So the expression will be in the form of an x power n, an minus 1 x power n minus 1, so plus and so on. A naught that is equal to that one is called polynomial. If it is equal to 0, then we can say that is function. Okay. Otherwise, if f of x equal to, which will be in the form of some x cube plus 2x square plus 9x plus 1. So this is called as polynomial. Okay, if it is a polynomial, then that is compulsory, that is continuous function. Okay, is it clear, all of you?
Yes, ma'am.
So every polynomial is a continuous function. Every polynomial is a continuous function. Don't forget that statement. That is most important statement. Okay, so now coming to the next definition, differentiable function. Differentiable function. So all of you write down the definition of differentiable function. A function f of x is said to be differentiable function if f dash of x exists at x equal to a. Okay, so a function f of x is said to be differentiable function if f dash of x exists at x equal to a. So what is the meaning of this? What is the meaning of this? A function f of x is said to be differentiable function if f dash of x exists at x equal to a, means that is
Definition of f of x should be exist at a.
yes,
That
okay,
is right.
means f dash of a instead of x, if we put a no, so f dash of a will be exists. Okay, so what is the formula for f dash of a? So that is nothing but limit x tends to a f of x minus f of a divided by x minus a. Okay, so this is the formula for differentiable function. So yes, listen all of you carefully. So I will give you three questions. Can you tell me whether the given function will be exist or not, or differentiable or not? Okay, so first question is, if f of x equal to x square plus 2x plus 1. So the limits are 0, 4. Okay, and next question, if f of x equal to 1 by x, so the limits are minus 1, 1. And if f of x equal to log x, okay, so here also same, the limits are minus 1, 1. So now tell me, so whether these three functions are differentiable or not.
Yes, ma'am.
Yes, all the three functions are differentiable within these limits. No. So I will tell you one clue.
No, ma'am.
Okay?
First one is
So first one is
differentiable.
Not differentiable.
Differentiable, ma'am.
first one is
Differentiable.
Differentiable, ma'am.
differentiable. What about
Second and
second one
third
and
is
third one?
no, ma'am.
Second one, no, man.
Okay. What about third one?
Third one, log x means 1 by x now.
Yes.
Don't know, ma'am, about third one.
Okay. No problem, no issue. So I will tell you how to check whether the given function is differentiable or not. I will tell you in shortcut way. So what is our f of x? So now check. So before that, I will tell you one thing. So if f dash of x, So you need to, here we have, they have given that f of x, right? Given function. Okay. So we need to find f dash of x. If that should not be equal to infinity. If that is not equal to infinity in those limits. Okay. In those limits, then we can say that that is the differentiable function. F of x is, here f of x is differentiable function. Okay. So if it is, if the differentiation is equal to infinity, so within the limits, okay, so within the limits, f dash of x is equal to infinity or within a comma b. Okay. So within a comma b or within the limits, if it is not equal to infinity, then the function is differentiable function. If the function is, if the differentiation of that function is equal to infinity, so then we can say that f of x is not differentiable. Is it clear, all of you? This is the shortcut way to find whether the given function is differentiable or not. Okay. So first you
Okay,
need to
ma'am.
find the differentiation. First of all, you need to find the differentiation. After that, check whether the differentiation of f of x is equal to infinity or not equal to infinity within the limits. Within the limits. Okay. So now coming to the first part. So what is the differentiation of this function? What is f dash of x?
2x
2x
plus
plus 2.
2x plus
F
2.
dash of x equal to
2x
2x.
Plus 2.
2x plus 2. Okay. So the differentiation of f of x is 2x plus 2. So is this will be exist in 0, 4? Let us take one point in between these 2 points. Okay. So already I have told, no. So always the differentiation will be exist in open interval a comma b, right? So always the differentiation will be exist in open interval a comma b. Why? So when it is derivable, no, in that case, unique tangent will be exist. Okay. So but the end points, more than one tangent will be exist, right? So many tangents will be there in the end points, right? So that's why at the end point, the differentiation does not exist. That's why we are taking open interval a comma b, excluding a comma b, the not including a comma b. Okay. So that is differentiation method. So here we need to check. We need to check the differentiation in between open interval a comma b. Okay. So that is open interval a comma b means here we have 0, 4, right? Okay. So let us take one point, one value in between these two. Okay. So that is not equal to infinity. Okay. So if I take f dash of 1, no, that is not equal to infinity. So that's why the function is, therefore f of x is differentiable. Okay. So now coming to the next point. So what is our next point? F of x. So now we need to find the differentiation of f dash of x. What is the differentiation of 1 by x?
minus 1 by x square.
Minus 1 by x square. Okay. So differentiation of 1 by x is minus 1 by x square. So that will be exist in minus 1 comma 1, right? Okay. So here I am taking, in between we have 0, right? In 1 comma 1 we have 0 in between. Okay. If I substitute 0 here, okay, is this equal to infinity or not equal to infinity?
Equal to infinity.
Okay. So 1 by 0, that is nothing but infinity, undefined function. So in that case, therefore f of x is, if it is equal to infinity, that means that is not equal to infinity means that is differentiable. If it is equal to infinity means the given function is not differentiable. Okay. Not derivable. Okay. So coming to this part, this problem. So what is the differentiation of log x?
1 by x.
1 by x.
Okay. So this should be
Become
existing.
infinity.
If I take 0 here, if I take x value is 0, then this will be f dash of 0 is 1 by 0, that is nothing but infinity. Okay. So that means if it is infinity, no, therefore the function is not differentiable, right? The given function is not differentiable. So like that you can find whether the given function is differentiable or not. Just you need to find the differentiation of f of x. Just you need to find the differentiation of f of x. So whether that value is equal to infinity or that is not equal to infinity. If it is equal to infinity, then the given function is not differentiable. If it is not equal to infinity, then the given function is differentiable. Okay, now all of you write down. Shall I erase?
Yes, ma'am.
Okay, so now all of you write down the note. This is most important note. Okay, so every differentiable function, every differentiable
Is
function
continuous.
is continuous function. Very good. Who's that?
Me, ma'am. Kaushik.
Very good, Kaushik. So every differentiable function is continuous function. But what about converse?
It may be or may not be.
Need not be.
Every continuous is not
Need not to be a
differentiable.
differentiable.
Need not be true. Okay, so every differentiable function is continuous, but every continuous function is may or may not be differentiable. Okay, the converse is not true. So all of you take the note of this statement. So most important statement is this one. So by using this one, we can find Rolle's mean value theorem and Cauchy's mean value theorem and Lagrange's mean value theorem. Okay. What about the absent is Naveen and the roll number 89? Nikita.
I'll check it right now, ma'am.
Okay. So tomorrow we'll discuss about Rolle's mean value theorem. Okay, so
Okay,
that is okay, that is our next first topic. We have only three theorems are there: Rolle's mean value theorem, and Lagrange's mean value theorem, and Cauchy's mean value theorem. Okay. Okay, ma. Shall I close the session? So what is your next class?
Engineering workshop, ma'am.
Workshop, ma'am.
Okay. So all of you change your name as roll number, amma.
I'll send you the list, ma'am.
Okay, amma.
In
Okay.